Okay, so here we are back to do number 12 on page 5 here. So when we look at this, we can see that there are no GCFs other than 1. There's no GCF. Because we have x to the 4th minus 81. So again, there's no x in the last term. And since the coefficient of the first term is just 1, there's nothing they're going to have in common other than 1. I look at this and I think, okay, I have 2 terms, they're being subtracted, I want to look for a difference of perfect squares. And this, again, is the difference of perfect squares. We know 81 is a perfect square because 9 times 9 is 81. And remember that anytime my exponent is even, divisible by 2, that's going to be a perfect square. So I can factor it into 2 binomials. The square root of this guy goes here and here. The square root of x to the 4th is x squared. The square root of 81 is 9. I want to have a plus and a minus. Okay, now, oops. We're not quite done yet. That was temptation, right? But then we want to look at it again and say, okay, what does anything here catch your eye again? Well, x squared plus 9, we're not going to be able to do anything with, and we'll talk about why in just a minute. But x squared minus 9, if you notice, that again is the difference of perfect squares. So I can now split that up into 2 binomials also. So I have x and x for the square root of x squared. And then the square root of 9 is 3, and I can have a plus and a minus. So now we're all set with that. We've factored that as much as we possibly can. So the next question there talks about this x squared plus 9. Can we factor x squared plus 9? Or anytime we have the sum of perfect squares instead of the difference, can we factor those? So let's take a look. If I have x squared plus 9, and I want to factor it. Well, if I have a plus 9 here, I know that means I have to have the same signs. So let's try x plus 3 times x plus 3. If I multiply those, x times x is x squared plus 3x plus another 3x plus 9. Well, my middle terms don't cancel out here, they add. So I get x squared plus 6x plus 9. So that's not going to work because I still have this middle term in here that I have to worry about. Well, another way to get a positive 9 when I multiply is by having 2 negatives. So let's try that. So x squared minus 3x minus 3x plus 9. Well, I have my plus 9, but again, my middle terms don't cancel out. They add together. So that's not going to work either. Okay? I need my middle terms to cancel out because there's no middle term here. Well, the only way to make those middle terms cancel out is if they have different signs, which would mean these would have to have different signs. But I know then, yes, it'll make the middle terms cancel out, but it'll give me minus 9 at the end, not plus 9. Okay? So we're going to say no here. We cannot factor this in the real numbers. Okay, again, in Math 120, you'll have some methods to do that, but for here, we cannot factor it with the real numbers. So we have to stick to factoring the difference of perfect squares, not the sum. So let's add factoring difference of perfect squares up here, and then we will move on to the next kind of factoring. Okay. All right, so factoring by grouping. So factoring by grouping, we use when we have 4 terms. And there's not a GCF for all of them, okay? Or we sometimes can take a GCF out, but then we still have 4 terms that we need to factor. So what we're going to do is we're going to take the GCF of 2 at a time. So let's say here in number 14 we have 2x squared plus 6x minus 5x minus 15. Okay, now you might look at this and say, well, those middle 2 terms are like terms. They could be combined, okay? And they can be, but just believe me for now that we're going to leave them separate, okay? This is kind of a middle step in the next type of factoring we're going to do. So we will end up in this situation sometimes and not want to combine these because we're working on factoring. All right. So if I look at this, and I'm looking for a GCF, a greatest common factor, if I look at the numbers, 2 comes out of these 2, but not those 2. And 5 comes out of these 2, but not these 2. And 3 comes out of these 2, but not these 2. And x comes out of the first 3, but not the last one. So I can't pull out a common factor out of all of them. And I can't just do 3, okay? It either has to be all of them, or if we can't, we're going to do this factoring by grouping. So what we're going to do is we're going to look at these 2 at a time. And we're going to factor out a GCF 2 at a time. So first, we're going to pretend that this part doesn't exist at all. And we're just looking at 2x squared plus 6x. And I'm looking for a greatest common factor here. So when I look, I can take a 2 out of these, and I can take an x out of these. So I'm going to pull out 2x, and just like before, in parentheses, I have what is left, which is x plus 3, right? There's another x here, and there's a 3 here. Then I move over to the second pair, and now I pretend that this part didn't exist, okay? I need to look at that negative. This minus in front of the 5x, I need to bring that with me. Either you can think of just bringing it down, or you can think that, again, because I have a leading coefficient that's negative, I'm going to pull that negative out. And what these 2 have in common is 5. So again, I'm going to put in here what's left from each one. So 5x and 15, I'm going to pull out a negative 5 from both of those. So here I have x left. Now this one, be careful. A negative divided by a negative is a positive, so I have plus 3. I always suggest that at this point, you, even in your head, if you're not going to write it out, distribute back to make sure what you have here gives you what you had here. So 2x times x is 2x squared, 2x times 3 is 6x, negative 5x, negative 15. If you notice now, what I have in the parentheses is the same between this term and this term. So that effectively now is my greatest common factor. If I think about what does this term have in common with this term, what they have in common is x plus 3. And then what I have left after that is what's still left, 2x minus 5. Okay, so if we're kind of looking at what happens there, I pull out the x plus 3. If I look at this term, if I divide out that x plus 3, what's left? 2x. And if I look at this term, once I divide out that x plus 3, what's left is negative 5. So that's what goes into the binomials. Okay, again, I can check it here also. X times 2x is 2x squared minus 5x plus 6x minus 15. That's what I have there. All right, let's do one more of those. And for some of these where we're doing, all of the examples on the notes, as I've said before, I said this in class during the semester, also when we were in person, a great thing to do is to copy down these problems on another sheet of paper, try them again, you have the answers there in front of you to look back at. Okay, so the next one is going to, I'm going to actually rewrite it up here so I have a little more space. Take this out of the way. So we have 2x squared plus 6x plus 4x plus 12. So this is number 15. Okay, so when I look through here, you might notice that there is a common factor. There's a common factor of 2. So let's pull that out. And we're going to have x squared plus 3x plus 2x plus 12. Oops, plus 6, sorry. Forgot to divide that one. Now, there are a couple different things we could do here. If you notice, now that I took that 2 out, what's in here is going to be an easier trinomial if I add these together. So at this point, I really could say this is x squared plus 5x plus 6. I want two numbers that multiply to 6 and add to 5, which are going to be 3 and 2. And I can factor it like that because I end up with that easier trinomial in the parentheses. But I can also keep going with factoring by grouping. That's fine too. So let's pretend we didn't notice that you could do that. I'm going to factor by grouping, 2 at a time. X comes out of these two, x plus 3. 2 comes out of these two. When I divide out the 2, I have x plus 3. I have this extra set of brackets around it because if I didn't have that, the 2 would only be multiplied by this. I have to put these brackets, or you can just put a second set of parentheses to show that the 2 is getting multiplied by all of this. If we look at this part now, these two have x plus 3 in common, and what's left is x plus 2. Okay, now let me show you something else with this one. Let's say that when you looked at this, you just didn't notice that there was a GCF. So instead, you just did factoring by grouping with the numbers that you had. Okay? Well, that would still work as long as you pay attention to what you end up with. So here, now here, my GCF is going to be 2x. So I'm going to take 2x out, and I'll have x plus 3. And here, my GCF is going to be 2. Oops, sorry, that's not true. It's going to be 4. So then I have x plus 3 there also. So once again, I look at what these two terms have in common is x plus 3 times. So they have x plus 3 in common, and then what's left is 2x plus 4. Now, when we're done factoring, or when we think we're done, we always want to look at our factors and see if there's anything more we can do to them. You know, is one of them difference of perfect squares or whatever? Well, here, x plus 3 is as simple as I can get, but if I look at 2x plus 4, that still has a GCF there of 2. So I can take out 2 x plus 2, right? These two things are the same. I'm pulling out the GCF, writing what I have left. And then generally, just to make it neater, these are all being multiplied, so they can be in any order, but we really would normally put that single term out front of these. Okay, so you can get the same place. If you got to here and didn't notice this, you'd get most of the credit, but not quite all of it. You want to get down to here. Okay, so that's factoring by grouping, and we're going to use that when we get into the last set of factoring here, which is factoring those harder trinomials. Okay, so that'll be in the next video in just a minute.